In this lesson, we're going to look at the quadratic formula, why we use it, where it comes from, and what it is. We'll start with a quadratic equation. Here, what we have is a quadratic trinomial set equal to 0. Now, if we wanted to solve this, one of the first thoughts is factor the quadratic and use the zero product property by setting each fact equal to 0 and solve for x. But what if this quadratic is not factorable? Let's sort of do a brute force and solve for x using what we know about balancing an equation. So let's start. I'm going to rewrite the equation. Let's take our equation and we want to remove the c. Remember, our mission is to, what we want to do here, our mission is to isolate x. So what I'm going to do is add the additive inverse of c to both sides. And when I do that, you can see here on this side I have 0. I'm going to add a negative c. When I add a negative c, on this side, the left side, my c's cancel out. So let's move these up a little bit. Okay. So now what I have on the left-hand side is ax squared plus bx is equal to a negative c. So remember, we're trying to isolate x. So my next thought is I want to get rid of the a that I have right here. One way to do that is to take the entire left-hand side and the entire right-hand side and multiply it by the multiplicative inverse of a, 1 over a. So I multiply the left-hand side by 1 over a and the right-hand side by 1 over a. Well, when I do this, I'm going to distribute it. I'm going to distribute the 1 over a to the first term, and I get, well, the a's cancel out. I get just x squared. When I distribute the 1 over a to my second term, I get plus b over a times x, and my right-hand term becomes a negative c over a. Okay, now let's take the left-hand side where I have x squared plus b over a times x, and I'm going to add to this side a b squared over 4a squared. And you see I've just added this to the left-hand side. So if I add it to the left-hand side, in order to keep this balanced, I have to add the b squared over 4a squared also to the right-hand side. Well, this move that I just did right here is called completing the square. By adding this term on the left-hand side, b squared over 4a squared, I turn this quadratic trinomial into a perfect binomial squared. And it's actually equal to x plus b over 2a all squared. If I FOIL this out, multiply this binomial by itself, I will get what you see up here. And this is equal to, well, if I look over here on this side and I want to add these fractions together, I need to multiply the top and the bottom of this fraction by 4. That gives me a 4a, so I almost have a common denominator. Now I have to multiply the top and the bottom by a to make the bottom a squared. And now I can add these together. And what do I have? Well, in the denominator, I have 4a squared. In the numerator, let's put the b first. I have b squared minus 4. I'm going to commute the a and the c, ac. Okay, I'm still trying to find x. And you'll notice that x is almost, it's actually, I only have one x here, so it's getting better. Let's take the square root of both sides. The square root of the left and the square root of the right. Well, when I take the square root of the left, I end up with the absolute value of x plus b over 2a. On the right, let's see, I have the square root of b squared minus 4ac, and in the denominator I can actually take the square root. The square root of 4 is 2, and the square root of a squared is a. Now, what I want to do is, in order to lift these parentheses, I'm removing them. This value that we see right here is either positive or negative. And what we can do is put a plus or minus over here, and that allows us to lift the absolute value sign. And now the last thing I'm going to do is I'm going to add a negative b over 2a to both sides. When I do that, I have only an x on the left. And when I add a negative b over 2a to the right-hand side, notice that I have this common denominator, 2a. So when I add it, or actually I'm going to subtract, or add a negative. So it's a negative b plus or minus the square root of b squared minus 4ac over 2a. What I've just derived is the quadratic formula. It's a fairly long process to derive the quadratic formula when we want to solve for x and our quadratic is not factorable. So rather than derive the quadratic formula each time, instead we know what it is, here it is, and we're going to use it. So here we have the quadratic formula. If we are given, let's start with our quadratic equation. A quadratic equation, ax squared plus bx plus c is equal to 0. And we want to solve for x, we're going to use the quadratic formula, or we can factor. But if we cannot factor, the only way to solve this for x is to use the quadratic formula. And incidentally, you can use the quadratic formula every time to solve for x. It's just that factoring sometimes is a little faster. And all you need to do this is the information that you need is what is a, what is b, and what is c. And then you plug them into the formula. The formula is a ratio, and it is a negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you might question why there's a plus or minus. That's because there are two possible values for x which you could plug into this equation such that the left-hand side is equal to 0. So this allows us to have our two solutions. We could do this whole equation with a plus and then work it out with a minus and get our two values of x. Let's move this up. And here, let's put a box around this. This is our quadratic formula that we will be using. And let's try this out. Here we have an equation. It's a quadratic trinomial. And let's start by changing the subtraction to add the opposite. let's solve for it. That is, let's solve for x if this equation is equal to 0. Okay? What we want to do is find x. So let's start by finding a, b, and c. A is 2. B is -3. And c is -2. And here we're going to use the quadratic formula that we have boxed in red there to find the values of x which will make this equation true. So we start with a negative b. A negative, b is -3. And we say plus or minus the square root of b squared. That's a -3 squared minus 4 times a, which is 2, times c, which is -2. Let's carry that over. And this whole thing is over 2 times a, and a is 2. Okay, so I just took the quadratic equation and plugged in my values for a, b, and c, and I got this. So let's work out what is this actually equal to. So I'm going to come down here, and I have a negative times a -3 is a +3, plus or minus the square root of -3 squared is 9, plus, and I'm saying plus because here I have it, this is really a -4, right? Plus, and I have a -4 times a -2 times a 2. 2 times 2 is 4. 4 times 4 is 16. I have two negatives, which make it sit positive. So this is 16. And I don't need this much. I guess I'm stuck with that. Okay. And then in the denominator, I have 2 times 2, which is 4. So let's keep this going. So this becomes 3 plus or minus the square root of 25. And we're getting closer to our answer, over 4, which is equal to 3 plus or minus 5 over 4. Now these are our values for x. Now we have to do a split. Let's split this up. We can either have 3 plus 5 over 4 or 3 minus 5 over 4. 3 plus 5 over 4 is 8 over 4, which is 2. 3 minus 5 over 4 is a -2 over 4, which is a -1/2. So my values for x are, x can be equal to either a -1/2 or 2. So this time we've solved our equation using the quadratic formula, and we'd want to take this and plug this back in to our original equation to make sure that these values are valid and they are solutions to this equation. Well, they are. And this time, rather than factoring the left-hand side and using the zero product property, we simply used the quadratic formula. Keep in mind, the quadratic formula works every time when you are solving a quadratic equation set equal to 0. So the quadratic formula is something that you should really memorize as we move forward. It's something that's very handy when we're trying to find the value of x in an equation that has a quadratic.